Let's take a look at this problem. The combined electrical resistance R of R1 and R2 connected in parallel is given by 1 over R equals to 1 over R1 plus 1 over R2, where R1 and R2 are measured in ohms. R1 and R2 are increasing at rates of 1 and 1.5 ohms per second, respectively. At what rate is R changing when R1 is 50 ohms and R2 is 75 ohms? If we know a little bit about physics, that would be great. But if we don't know, doesn't mean that we cannot handle this problem. Let's take a look at this problem carefully. The combined electrical resistance R of R1 and R2 connected in parallel is given by this equation. And that is important. So maybe we write it down on the side. 1 over R is equals to 1 over R1 plus 1 over R2. This is an important equation we need. Where R and R1 are measured in ohms. R1 and R2 are increasing at rate. Increasing at rate. We are talking about the rate of change, the derivative. So we have the dR1 by dt of 1 and 1.5 ohms per second. Now, so that is the derivative with respect to time. Sometimes the units give us a little bit hint, ohms per second. Second is the unit for time. So the dR1 by dt is equals to 1 ohms per second. And the dR2 by dt is equals to 1.5 ohms per second. At what rate is R changing? So the question is asking us, let's find the dR by dt. When R1 is 50 ohms and R2 is 75 ohms. So when R1 is 50 ohms and R2 is 75 ohms. So that's it. We transfer the whole work problem into a simple math equation. Let's take a look at how we're going to handle this now. We know the formula. 1 over R equals to 1 over R1 plus 1 over R2. Now take the derivative of both sides with respect to P. So we have this. And take the derivative of the left-hand side. We need to use the implicit derivative. So that would give us negative 1 over R squared times the dR by dt. Now, at this point, probably it's better that we refresh our memory. How do we take the derivative of 1 over x with respect to x? That will give us negative 1 over x squared. Now, if you remember this, that would be great. How do we get that? Let's refresh our memory. We will turn the 1 over x into a power function like this, x to the -1, and then we can use the power rule to take the derivative. We bring down the exponent and then decrease the exponents by 1. And then finally, we turn it back into the fraction form like this, negative 1 over x squared. Now, so go back to our previous page. So let's see. I want to take the derivative of the right-hand side. So the sum and the difference rule, take the derivative of the first term, 1 over r1. So that would give you the negative 1 over r1 square dr1 by dt minus 1 over r2 square dr2 by dt. Now we want to look for dr by dt. We know what is dr1. We know what is the dr1 by dt. We also know what is the r2, and we know r2 dr2 by dt, but we don't know what is the r. But what we know, when r1 is equals to 50 and r2 equals to 75, we have 1 over r is equals to 1 over r1 plus 1 over r2. That means 1 over 50 plus 1 over 75. That gives you 1 over 30. So in another word, we can tell the r at this point would be 30. So now we substitute r equals to 30, r1 equals to 50, r2 equals to 75, dr1 by dt equals to 1, and the dr2 by dt equals to 1.5 into the previous equation. We are talking about this equation. So we will have giving negative 1 over 30 square dr by dt equals to negative 1 over 50 square times 1 minus 1 over 75 square times 1.5. Then we will get negative 1 over 900 dr by dt equals to negative 1 over 1500. So solve for the dr by dt, we will get 3 over 5, which is equals to 0.6 ohms per second. Now don't forget at the end, let's answer in wording. Therefore, the rate of change of combined resistance R is 0.6 ohms per second.